Hello all, welcome to Azure Monitor Virtual Series. In this session, we'll be covering some of the best practices and recommendations that would be useful to you as you move along your monitoring journey with Azure Monitor. When you're thinking about monitoring, it's usually very useful to split your monitoring lifecycle into 6 distinct phases. And there are specific best practices associated with each of these phases that we will deep dive into. We'll talk about how do you plan your monitoring strategy to begin with. We'll discuss how can you best design your overall monitoring architecture. How do you then onboard your environment at scale to be effectively monitored? Once you have done that, how do you set up automations and remediations and basically operationalize your entire environment efficiently? We'll talk about optimization, both in terms of implementing monitoring in your environment, as well as setting up robust diagnostics capabilities. Lastly, we'll discuss some of the best practices around effective communications and collaborations with your DevOps and IT SRE teams. Let's start from the first phase. How do you start planning your monitoring strategy? Now, the first golden rule is always have a plan. It's no good starting your monitoring journey without understanding what do you really want to monitor, who are the stakeholders, who needs to be notified. And according to your scenarios, you also need to have a very clear idea of what your SLAs are going to be, if you have any specific urgency or latency considerations that might affect whether you use metrics or logs or what specific data types. And according to your geography, your organization and company compliance rules, you might have certain data privacy, retention, residency, or compliance requirements, which it's always a good idea to be clear before you start architecting your environment. The thing you need to be fairly clear from the beginning is what kind of monitoring solution you would be using. Microsoft provides various types of monitoring solutions out there, depending on your needs. So if you have most of your environment in Azure, if you're a cloud native user, Azure Monitor is a great cloud native full stack monitoring solution, which even works excellently well in a hybrid monitoring scenario, including if you have Azure Arc based resources running on-premises or any other third-party cloud providers. Plus, there is also System Center Operations Manager, or SCOM, if you want a more dedicated on-premises deployed solution, or if you have much more complex needs around workload monitoring or health monitoring on your on-premises servers. Also, if you're already using any third-party monitoring tools or ITSM tools, and you want to connect Azure Monitor or SCOM, there are a bunch of extensions and integration capabilities out there. We provide a couple of great tools that you can start exploring. There is Microsoft Cloud Adoption Framework, which is a great starting place that can help you with your cloud monitoring strategy. We'll talk about some of these in this session. So it can give you some ideas around how do you set up data collection, how do you set up an effective alerting strategy, and so on. There is also a much broader Azure Architect Center, which can give you additional architectural guidance and a bunch of frameworks and best practices, not just around monitoring, but the entire Azure space in general, including management, security, networking, and so on. Just to see how that looks, this is the cloud monitoring guide that you'll go to. And under the Manage section in monitoring, you'll find a bunch of resources here. So what are the different cloud models that we have? How do you set up data collection, alerting, as well as any specific skills you need to get proficient in if you want to improve your monitoring experience. Similarly, on the Azure Architecture Center, if I just search for monitor, I'll find a bunch of different resources that might be useful to start picking up best practices. So that's the first phase. At this point, you should have a pretty good idea on what you are trying to achieve in terms of monitoring. Now, how do you start designing your overall monitoring architecture? Now, the first thing you need to figure out is how do you set up your log analytics workspaces? So you heard about Log Analytics workspaces today. This is essentially our centralized data platform across all telemetry that we are collecting, not just in Azure Monitor, but across different data sources. So including networking, security, compliance, a whole bunch of things. So every data from Azure, every telemetry or log data comes into your Log Analytics workspaces. Now, a best practice here is to use as few of these workspaces as possible, basically depending on your organizational requirements or any geographical or data sovereignty constraints. In terms of data access, you can very well implement a hub and spoke model where your central IT or ops teams can have access to all telemetry with direct workspace access, while your individual feature teams might only be satisfied with just the resource access and not have access to your entire telemetry. In terms of data retention as well, you are not constrained to retain all data for all amount of time. You can set up variable configuration. For example, if you want security or audit logs to be retained for maybe 2 years, whereas your diagnostic logs you only need for a couple of weeks, you can set it up very, very effectively. And there is this documentation here, aka.ms logs design, that can give you much more starting guidance on how to do this. Just like workspaces, on the application side, when you're using application insights to monitor your client-side or server-side applications, you need to similarly figure out whether you use a single App Insights resource for all of your applications or separate ones. Now, there are pros and cons and best practices around both these requirements. Separate resources are useful when you want to save costs or prevent data mix-up, or essentially they are distinctly different applications owned by different groups. Similarly, a single resource might help you retain all relevant telemetry in the same place, where you can still filter or segment based on the dimensions and properties that you're collecting. Now, as an example, if you have different independent applications, as I said, separate IKEys is the recommendation. IKey is essentially your application insights primary key. Another example, if you have dev, test, and production environments, and you are flowing your application through each of these stages, it's a good idea to use separate IKeys because at the end of the day, they are separate independent applications. On the other hand, if you have a microservices architecture or you have multiple roles of a single business application, consider these as an application as a whole. So using a single IKey usually works most effectively, wherein you can still filter or segment using the cloud role name property of those applications. In the same way, if you're doing A/B testing, it's still the same application, just things differ within an application from a user experience perspective. So you can always add custom properties to identify variants. Another useful thing when designing your architecture is in terms of what your network configurations are. It works very well on a fully cloud native public internet fashion. But what if you have virtual networks? What if you have on-premises resources, intranet servers that you want to monitor? So it's a good idea to evaluate your network configuration requirements. And if you want to use Azure Monitor to monitor your firewalled or intranet resources, there are documentation out there in our repository where you can set up firewall exceptions, proxy redirects, or even use a log analytics gateway to monitor your intranet servers. Our synthetic availability tests can also be run on an intranet server through similar firewall doors, or you can even use your own custom tests and send us the data using REST APIs. So at this point, you would have a fairly well-designed monitoring architecture in place. The next step is onboarding your resources and effectively doing that at scale. Now, if you're only monitoring a few handful of resources, you might very well be able to do that on a manual basis, going to the Azure portal, clicking a couple of buttons, and be done with it. But in typical scenarios, you might have tens or hundreds of servers or applications or containers that you're trying to monitor. Now, how do you do that at scale? The first half of the process is around infrastructure monitoring or platform monitoring. Now, you will need to basically identify differences between different types of agents or diagnostics extensions or data coming in from diagnostic settings. In this documentation, aka.ms agents overview, you'll get a fairly good idea about the different types of agents and extensions that we have. So if we come here, we can actually see in Azure Monitor documentation, you'll see an overview of Azure Monitor agents. So depending on what your servers are, Windows or Linux, there are various different types of data collection mechanism available, each satisfying a different scenario or a requirement. So if you go through this short article, this would give you a fairly good idea about what you need to consider, what kind of agents are useful for you. Once you have done that, there are diagnostic settings to be aware of as well. Now, these diagnostic settings are essentially used to route logs from your Azure platform resources and store them in log analytics for queries, or even archive that in storage or send it across to event hubs if you're using any third-party analytics or CM solutions. Do consider that metrics from these same platform resources are collected by default, so you don't necessarily need to configure anything there. Now, once you're aware of what agents or settings you're wanting to use, the last step here is to essentially set up automation. So these configurations can be done on an automated basis. And again, there are various options depending on what your overall architecture is. So if you're using Azure Automation, you can set up desired state configuration using these settings. You can use PowerShell or CLI samples to get you started. Most of our tools support Azure Resource Manager templates based onboarding. And some of our tools like VM Insights or diagnostic settings are also enabled through Azure Policy. So to get a view, again, there are various documentation articles available throughout our documentation, which can give you like PowerShell samples, CLI, ARM template samples, which can essentially help you get started. So that was the workspace thing. If you're looking at another article, we talked to you about how to create diagnostic settings using ARM templates. And I'm not going to go through each and every article here, but you get a picture. So there are articles about alerting, about setting up VM insights or container insights using these similar at-scale mechanisms. And on the Azure portal, if you're using Azure Policy for your governance and compliance mechanisms, there is a whole category of monitoring policies or initiatives that you can set up in your environment. So in my demo environment, for example, I have a bunch of monitoring initiatives in place. So for example, enable Azure Monitor for VMs, for VMSs. And there is even a custom initiative I have set to deploy diagnostic settings via policy. So using these policy-based initiatives, it becomes very easy for any new resource that comes up into your environment. It can follow your baseline policies that you have set up and help you evaluate whether all your resources are in compliance with your monitoring needs. So that's on the infrastructure side. When you come to application level monitoring or microservices monitoring, there are a couple of things to be aware of. Our standard recommendation is if you can use codeless attach mechanism for your applications, that's usually the easiest approach and the easiest to basically manage like all of your updates very effectively. So if you have apps running on Azure App Services or Azure VMs or Azure Kubernetes services, depending on your programming language and exact environment, we do support codeless attach or agent-based mechanism of onboarding. We even have an agent for apps running on-premises on Windows servers or VMs. Now, these agents or codeless attach collects the same telemetry or same dependency signals that you would otherwise collect if you instrument your apps with an SDK. That's why we only recommend instrumenting with an SDK if you have requirements of sending custom instrumentation, or if your environment is not yet supported through the agent, or you just want to do specialized customizations or configurations into your data instrumentation. As part of your DevOps process as well, there is an integration mechanism that's very effective to include it into your CI/CD pipeline. So if you're using Azure pipelines or Azure DevOps projects, application insights can very well be integrated as part of your release management process. So there are templates out there that can help you instrument and onboard to app insights as your apps go from dev to test to production. So at this stage, you have monitoring set up across your platform resources, your infrastructure, and all of your applications are running pretty well. The next step is figuring out what goes wrong and immediately or as soon as possible being able to do something about it. So you want to be able to detect, triage, and diagnose problems as quickly as possible, and even remediate them or auto heal them as much as possible. So the first step here is configuring alerts across your system. And a golden rule here is only set up actionable alerts and never, never, never spam your colleagues. Now, how do you go on about that? If you're using an SLI, SLO kind of a framework, it's a good idea to set up your alerts in that same basis. So you can use all of your SLAs and configure alerts accordingly using your thresholds that you have set up. Once you start setting up alerts, you would notice you get two options. There is either a metric-based alert or a based alert. The recommendation here is if you can use a metric-based alert, it's always preferable because it will provide you better performance, better latency, and better management experience. On the other hand, a log-based alert is much, much more powerful. It can give you much complex queries to trigger your alerts based on and give you much more control over what you are trying to query there. Or simply, there might be cases where you don't have metric for that particular situation. Also, while you're setting up these alerts, do define a proper severity or a description model. So you are not spamming or sending blanket notifications to people who cannot take any action. And if I get a notification, I should at least immediately be able to figure out whether it's something I need to be involved in. Once you have set up these alerts, you also need to consider setting up a very, very customized management workflow according to your organizational needs. So there are some organizations, some of you might be using ITSM systems like ServiceNow, Cherwell, Provence, or ticketing systems like PagerDuty, VictorOps, and various other tools out there. So it's a great idea to connect these alerts with your ITSM and ticketing systems for efficient management. In cases where you can do auto healing and remediations, there are tools that we provide out of the box. So there are automation runbooks that you can use to do things like restart a VM or restart your app service or any custom runbook that you want to set up. Or you can use logic apps to do custom workflows like in custom email or taking some custom action based on that trigger. There are action rules available as well that can help you manage these alerts at a broader policy level scale. So you can set up suppression logic or configure actions at scale. As an example, you might want to say that all severity 0 errors or alerts in your environment, you immediately want a voice call or a push notification, but any other alerts out there, you are satisfied with just an email. Now, to see how that looks, if I come to Azure Monitor, come on alerts, that's how it will look here. So in Azure Monitor, I have alerts. If I click on new alert rule, I'll come to this screen. Now, there are 3 things you need to create an alert. You need to define what you want to alert on. You need to set up a condition that needs to be alerted. And then you need to define what actions need to be taken. So in this case, I have set up a multi-resource metric alert. So essentially picking up all VMs in this particular region in this subscription. And it's an auto grow situation. So any new VMs that can added, the same alert would be configured on them. So setting up a condition, I had to choose between a metric or a log-based alert. I chose metric in this case. If I expand the chart period, I can see what the time series metric looked like in the last 24 hours, and I get an option of a static versus a dynamic threshold. So in this case, I have chosen a dynamic threshold, which is again a best practice when you are doing these alerts at scale. In this case, I don't have to worry about setting up static thresholds. So all the VMs that I have in my environment would have their own highly customized minimum and maximum thresholds set up according to their sensitivity levels. So in this case, if there is a regular spike in my VM performance, if that's the natural behavior, they are no longer considered an anomaly. So once I have the condition set up, I need to set up an action group. And if I create a new one, I can see that an action group is essentially a compilation of different action types. So once I come here, I can select runbooks or functions or logic apps or ITSM or even simple notifications to do whatever custom workflow I need to do. Another thing that you can do to manage your system at scale is set up auto scaling. Now, this is useful in an elastic environment. So if you're using resources like VM Skillset or app service environments, auto scaling can help you grow your environment elastically based on need. So you can use in-host metrics, guest metrics, or app level metrics and grow your environment according on a schedule or on a runtime metric like CPU usage or memory usage. That way, you can proactively take action when you are expecting a load or a synthetic spike, let's say during a holiday season or like a shopping day. So let's talk about you have everything set up. Now you want to further optimize and iterate on your implementation, improve your diagnostics experience. Now, the first good idea here is if you are trying to make your system robust, use some kind of simulated load testing to test if a spike happens or a load happens, is your system resilient enough or robust enough to handle that? There are various free open source tools available out there like Apache JMeter. Some commercial services are out there as well. And for .NET apps, code-based testing, there are another good set of examples out here that you can start using. Another good idea in terms of optimization is to use as much machine learning as possible to get proficient in AI ops and using these smart diagnostics capabilities. We already saw dynamic threshold-based alerting that is powered by machine learning when you're trying to do scalable anomaly detection. There are also raw queries that you can write in log analytics. So there are machine learning queries that can help you do much more. So as an example, there are a bunch of time series queries like series decompose and so on that can help you detect seasonality, detect anomalies within them, or even do time series forecasting. And then there are some machine learning proprietary algorithms that our research team has built that can help you identify common patterns of attributes, find frequencies within them, and even compare different data sets and identify what common patterns exist between them. All of these tools are very, very effective when you're trying to troubleshoot issues or diagnose root cause. The other important area here is, which many of you might have a question, how do you optimize your cost? How do you only collect and retain as much data as you need? This becomes more and more important as you grow your monitoring footprint. Now, one important point to keep always in back of your mind is only collect required information or required logs and only collect it at the frequency that you are interested to consume in. It's not useful to collect everything and retain it for all the time if you're never going to use it. You can also set up appropriate data caps to avoid any bill shocks or data anomaly spikes. There are sampling tools available. There are like ingestion sampling and adaptive sampling that can help you reduce telemetry items that are actually sent from your apps and even then get statistically significant information. You can even set up variable data retention that we talked in the beginning. There is capacity reservation pricing as well. So if you can commit using a certain set of data ingestion on a daily or monthly basis, you can get appropriate discounts for that. And we also provide recommendations from Azure Advisor out of the box that can help you optimize your cost and various other metrics like availability, security, and performance. To get a sense of that, if you go to your log analytics workspace, you'll notice there is this usage and estimated costs section. Here you can set up your daily caps, data retention, and even figure out what pricing tier you want to use here and what is contributing to your cost. Like in this case, most of my cost is coming in from log management solution. The second highest is container insights and so on. So this can help your IT teams or admin teams figure out what's being used and what you can further optimize. So the last thing we are going to cover here is setting up effective communication protocols and collaborate with your teams as effectively as possible. So the first thing here is when you are working with your colleagues, you need to decide what level of data access you want everybody to have. So you can use Azure's role-based access control and set up these data access rules accordingly. Now, Azure Monitor provides two specific roles for monitoring reader and contributor that only grants access to monitoring data while restricting any other access to those resources. Further, there are additional roles that we provide that can further restrict access to sensitive data like debug snapshots or mini dumps or code level data that we are collecting from exceptions or failures, which only the teams that need access to can be given. Then, if you want to set up further collaboration as part of your existing DevOps or SRE tools and processes, as we mentioned before, using Azure Logic Apps, you could set up these custom workflows. So some examples here are if you're using, let's say, DevOps or GitHub or Jira to do your bug management or work item management, you can create bugs automatically whenever an alert gets triggered. Similarly, if you're using Teams or a Slack channel for your chat ops purposes, you can always configure a Logic app to send you a notification whenever there is an alert. Or if you're using Azure DevOps to manage your CI/CD pipelines, you can use these alerts to effectively act as quality gates from your pre-production or post-deployment workflows. So let's say your canary to prod deployment can be halted if a particular KPI is not met or an alert is triggered. For your developers, all the production telemetry can even be accessed in their IDE, in Visual Studio, so they don't necessarily need to get out of their dev environment if they want to do debugging, diagnostics, or any kind of root cause analysis. Lastly, in terms of visualization, so we'll look at some of the examples, but depending on your specific needs, there are different visualization platforms available. So if you want to create a situation dashboard, there are Azure portal dashboards that we provide. If you want a more operational focused dashboard, Grafana is a native integration that we have that's very, very effective. And then we provide something called Azure Monitor workbooks that are very, very powerful and highly customizable to create whatever sorts of interactive reports you want to create. You want to make your own troubleshooting guides, or let's say end-to-end analytics or health dashboards. And lastly, at a more higher level, if you want, let's say, a business level dashboard or a KPI dashboard, you can always get your data in Power BI or export your queries to Power BI and create those reports out there. So just as an example, how that would look, here is my Azure dashboard that I have customized at a 360-degree level. So I'm getting my application level telemetry here. On the right-hand side, I'm getting my infrastructure level telemetry, VM, container, networking, even kind of an alert summary, security metric. So I can customize this dashboard as and how I want, do that at scale, share it with my colleagues using the same RBAC control that we mentioned before. Similarly, if I want a Grafana-based dashboard, we are one of the templates or plugins within Grafana. And as an example, here is a container operational dashboard that we have set up, which is just collecting that same data from Azure Monitor, including our Prometheus integration, and giving you a starting template on a similar kind of dashboard that you can further customize. That's the best practices we had, and some final words of advice. As we started, do always have a plan. Don't go ahead without that. Understand what needs to be monitored, who needs to be notified, and how your resources would be organized. As much as possible, don't try to manually configure everything. If you can, automate your monitoring environment. Also, don't try to monitor everything, collect every piece of data, retain it indefinitely. Your data needs to be actionable, so do think about that. Never spam, never send tons of emails if you don't need to. And don't consider copying exactly what you did on premises. Your cloud environment is fairly different from your on-premises environment, and your monitoring needs might be too. So with that, thank you all for watching. Glad to help with any questions that you might have now.